Hi, today is June 13, and today I will be talking about my review and summary of the research paper TrainingPal, an algorithm for recognition and counting popular exercises using smartphone sensors. The purpose of this research paper is to prevent chronic diseases such as cardiovascular diseases and type 2 diabetes by recognizing 10 different types of exercises and counting the number of repetitions for each exercise. Mm. So, there are four participants collecting the data who performed 10 activities in multiple sessions with a smartphone attached to their arm. There are two modules for this TrainingPal algorithm. The first module classifies the type of exercise, and the second module counts the repetition for each movement. The first module basically took each timestamp, calculated a 12-dimensional feature vector with two sets of three Euler angles from the XYZ axis of the accelerometer and gyroscope data. And after calculating the features, for classifiers, support vector machine, bag of decision trees, k-nearest neighbor, and discriminant analysis were trained to individually classify each timestamp from the 12 features. The second model of the TrainingPal algorithm, which whose purpose is to count the repetition of each exercise, included a smoothing filter and a peak-valley detection and matching unit. This module included 7 signals from the 3 axes of the accelerometer signals, the 3 axes of the gyroscope signal, and 1 dominant axis of the magnetometer signal. For each exercise among the 7 signals, 3 signals with the largest standard deviation were extracted, and the local extrema from the signals were used to represent repetitions. So the sampling rate for the sensors was 0.01 seconds. And for each timestamp, um, the features were calculated for that timestamp, and the timestamp was classified and assigned a label. Since the sampling rate for the sensors was pretty high for exercise classification, the 100 timestamps were grouped together, and using majority voting, a single label was assigned to each group of 100 timestamps or each second. Mm. This research paper used leave one subject out cross-validation and leave one set out cross-validation. And in the end, they calculated the results and the accuracy for each um, each classifier and with each cross-validation technique. So there are many innovations in this research paper. The first innovation is that the researchers leave one subject out and leave one set out cross-validation, which is pretty unique. A second innovation is that this research paper generated the Euler angles from the signals as features instead of calculating morphological and entropy-based features like in many other papers, or simply using the raw sensor data. And a third innovation is that this research paper included many types of more complex exercises. So instead of just having running and walking or jumping jacks, they had more complex exercises such as bench dips and lunges. I did find several challenges from and unclear details from this paper. A first major challenge is that because there are so little volunteers, the model is undergeneralized. This is shown by the unstable leave one subject out and leave one set out cross-validation results. The paper proposed that to solve this issue of undergeneralization, the TrainingPal could ultimately be personalized to its owner and learn its owner's movements. So undergeneralization would not be an issue. But then, if so, the model would have to continuously change its parameters, which is hard to achieve and implement. So overall, I think if this training pal were to be used in real life, the model would have to be trained with more subjects' data. Additionally, another major um, challenge is that the model does not make use of temporal relationships. In the model, each singular timestamp is classified with a label, and then 100 timestamps or 1 second of timestamps are grouped together, and the most common label from the 100 timestamps is chosen is assigned to that second. However, the model does not take in or make advantage of the patterns in the data points in the signals. And this may this will lead to like a decrease in performance. And I felt like if the model took advantage of the patterns and the temporal relationships between the data points instead of just individually classifying each data point, that would achieve much higher results, um, probably. So, so that is the end of my review and summary of this research paper. And yeah.